So let's get started. So first, let's understand what do we mean by prime numbers, right? And then the composite. So definition says a number having only two factors, right? Basically, one and the number itself is known as a prime number. So first, let's spend a couple of maybe a few minutes on the factors part. So when I say a number like 24, what are its factors? So factors are basically the numbers which can divide this number and leave a remainder of 0. Like 1, 24 when divided by 1 leaves a remainder of 0. 2 also same. 3 8s are, so remainder is 0. 4 6 8 12 24. Right, these are all the factors. So if there is a number like let's say 3, right, the factors are just 1 and 3. See, a number having only two factors, 1 and the number itself, is known as a prime number. So this is a prime number because 24 has factors other than 1 and the number itself. So this is a composite number. A number which is not a prime number, we can call it as a composite number. There is an exception, we'll come to that. And so this is basically the definition of a prime number, right? So a couple of interesting points to be noted is basically 1 is neither prime nor composite number, right? That's an exception. And 2 is the only even prime number, because every other even number like 4 6 8 10 etc always would have 2 as a factor. So that's by default violating this idea of prime number. So that's why only even number which is prime is 2, right? That might help you to solve some problems, so keep in mind. And 1 is neither prime nor composite, also please note this point. So how to find if a number is prime or not, right? So I mean, if you are used to it, you can easily list out numbers like 2 3 5 7 11, right? Prime numbers like 13 and so on. But what if I ask you if a number like 173, is it a prime number or not, right? So it will take you some time or effort to actually find out by maybe checking by dividing with each and every number and see if the factor. So what do you do for this? Step 1, find the square root of the number, right? So that means I'll try to find square root of 173, right? The closest integer I'll take, let's say this is basically 14. 14 square is 196, so 13 square 169. So I'll go with a bigger number. It's good to go with the bigger number. So now list the prime numbers less than the less than the square root we found out. So that means less than 14 in this case. So 2 3 5 7 11 and 13, right? These are the prime numbers I have. So just check for this. Check for these numbers, right? If they can divide 173. So 2 cannot divide 173. 3 also cannot divide 173. 5 obviously can't. 7 7 twos are 14. 33, 7 4 are 100, so the remainder is 5. So 11, 11 ones are 11, and 11 fives are 55, remainder is 8. 13, 13 ones are 13, and then you have 43, so 13 threes are 39, so again a remainder of 4. So here, if you know the divisibility rules, which we have covered in another video, you can actually save time for 2, 3, 5, 11, etc. if the number is even bigger than this. But yeah, so you just have to check for this because none of the numbers can divide. That implies 173 is a prime number. If I actually can divide with any of these prime numbers like 173 and it is divisible, that is leaving a remainder 0, that case I can say 173 is obviously not a prime number. So this effort actually minimizes your overall effort because you are just trying to check for few numbers. Otherwise for 173 you might have to spend a lot of time figuring out, is it divisible by 31, 37, whatever, right? So this is a best way to actually find out if a big number is prime or not. So now let's get some practice with few problems. What we suggest you is pause the video, try these questions on your own for some time, and then please look at the solution to get an understanding. Right? So I'm asking which of the following numbers are prime numbers. So first focus on 319. So again, the step one is finding the square root of it. The closest one would be something around 17. 16 is a 256, so 17 is 289. I think 18 to 19 is a decent. We'll go for 18. What are the prime numbers less than that? 2, 3, 5, 7, 11, 13, 15, 17. 17, right? So 319 divisible by 2, no. 3, no. We can check with 3 as well, but if you know the divisibility rule of 3, some of the digits should be divisible by 3. So that's 4 plus 9, 13 is not divisible by 3. So I can 5 also, yes. 7 4s are 28 and 39. So 7 5s, so the remainder is 4. So 7 is also not a number, right? 11 ones are 11. Sorry, 11 twos are 22. So I get a 9. So 11 nines are 99. So it is divisible by 11. So that means it's a factor. So I don't need to check for others. I know that 319 is a composite number. It's not a prime number because it is divisible by 11 into 29, right? See, next 427. Again, same logic. I do square root of it. It's approximately about 20. So I can take 21 squares, 441. So same again, 2, 3, 5, 7, 11, 13, 17, and 19 are the prime numbers. 427, is it divisible by 2? No, because it's not an even. 3, 6 plus 7, 13. Again, no. 5, no. 7, 6 are 42. And 7 ones are 7. So it is divisible by 7. So 427 is not a prime number. Right? And then for 624, you don't need to even do the square root because I know it's an even, right? 4 is the last digit, so it is an even number. So any even number other than 2 is a composite number. Right? Only 2 is the prime number which is even. So we can save time if you ever get a question like this.